So suppose you have this following function and we're trying to find dy dx when x is 4, or dy dt when x is 4, given that dx dt is 2 when x is 4. Now, we've talked about this from day one. We are deriving all of related rates in respect to time. So all of these are going to have dt's on the bottom. Okay? So let's go ahead and look at our function right here. It will be dy over dt is equal to 10x times that chain piece of dx over dt. It's not just 1, because we're not in respect to x. It's going to be dx dt, because we're in respect to time. And then we're going to do minus 6 dx dt plus what? Anyone? What's the derivative of 2? 0. Okay, so all constants are still 0. All right. So now I know that my dy dt is what we're looking for. And we're going to plug in the pieces that they gave us. They said when x is 4. And then when dx dt, let's do that here, is 2. So this would be 2, and this would be 2. So we have what? 40 times 2 minus 12. Anyone? What's the answer? 80 minus 70, or 12 is what? 68. So dy dt is equal to 68 when that. Are we good? All we did was reinforce the fact that we're deriving it in respect to time, no longer x. And now we're just going to substitute all pieces in to solve whatever that one unknown is in the very end. Any questions? Yeah. No. Okay. So let's move on. Here we go. I'm going to give you levels of these problems, and we will experience a couple of level 9s. I won't give you level 10s, but we will do 9s. Let's call this one a level 2. Okay? Now, because this is so difficult historically for people, and a lot of people dread this unit, I actually made an acronym that may help you. This is your acronym that you can use every single time, and I promise you will get all the pieces you need and you will be able to solve this out. If you've been in a physics class and you like shortcut approaches, well then use them after you've developed a good awareness of dreads. Because I promise you, dreads will be the clearest and easiest way to approach these problems. Because these problems are not the same. Conceptually, they are the same. But how you set them up and the progress through them, they're not going to be the same. So I want you to understand the how and why, what you should do next. Okay? Here we go. Number 1 is the diagram. Draw it. Make it very clear. Make it very neat so you can see what the setup is and what you're looking for. 2 is what are the rates? Otherwise, what are the slopes? What are the f prime of x's? What are the velocities that you're given in the problem? Okay? So the rates that are given and the ones that are unknown, the ones that you're trying to find, you're establishing those. Okay? Step 3 is you need to relate all your pieces together and see what equation does this even involve? What equation do all these little pieces involve? And then A is for ask. You're going to ask yourself 2 questions. Okay? Question 1. You're going to ask yourself, is the variable changing throughout the problem? So, is variable changing throughout the problem? The second one is, should we leave it as that variable, or should we write that variable in terms of a different one? So, in terms of is your second question. After you've answered those, you'll go on to take the derivative. So you're going to differentiate or find the derivative. And then last but not least, you're going to substitute what you know, just like we did on the last question where we substituted all those pieces that we were given. but then we're going to also solve for the ones that we didn't know. All right, let's go through this. And some of you, some of these questions you may not be, I guess, used to the setup or not, maybe because you've never gone fishing or you've never done this or you've never done that. Just try to look at the geometric pieces that are involved in the problem. Not necessarily, I got to go fishing to understand this problem. You know what I mean? So let's start for the first one. A pebble is dropped into a calm pond, causing ripples in the shape of concentric circles. So if you've ever done this, you know that those ripples come out from the pebble into concentric circles. And it goes on to say that the radius of the outer ripple is increasing at a rate of 1 feet per second. Okay? All of these things that I'm highlighting are very, very important. Okay? When the radius is 4 feet, find the rate at which the area is changing. All right. Bless you. Let's go through it. The diagram, I can add a little bit more and say when the radius is 4 feet, we're trying to see what is happening. So hopefully you did a little bit of homework, you watched Inception. Basically at one instant in time, so many things could be happening. The position, the velocity, the acceleration, all at that one act moment. Okay? That's what we're examining here. We're examining a snapshot in time. Okay? A snapshot that does have actions occurring, but you just can't see it because it's a snapshot. It's just a standstill snapshot. Alright. Diagram done. What is the rate that was given to us? 1 feet per second. Now, because it's increasing, is it a positive or a negative one? It's a positive one. Now, what we need to assign it, see, here's where I want you guys to do diagonal slashes. Only with units, please. Don't do it with numbers, okay? Only with units. What am I going to do with this? I'm going to do d something dt to represent this rate. What would y'all want me to use? dr. Yeah, dr dt. And the reason why I chose r was because it was the first letter of what's changing. Okay? When the radius is 4 feet, we're trying to find the rate that the area is changing. What should that be? D what? dA dt is equal to what when r is 4 feet? Again, I chose A because it was the first letter of that thing that I'm looking for. Okay? So dA dt is equal to what when the radius is 4 feet? Are rates given and unknown? Check. Anyone, what equation do you think this all involves? Pi r squared. This all will involve the area formula for a circle. So I'm about to pass out an equation formula chart that there are some that you're going to have to memorize for this unit. Let me pause the video. Okay, so our equation that we established is now checked. It was A is equal to pi r squared. Now, this is where people get a little bit confused. These two questions that you're going to have to ask yourself will make these problems a lot easier for you work-wise and when you start differentiating implicitly. So ask them very well and make sure that you understand how to answer them. Number one, is the variable changing? Okay? So looking at it, let me highlight just the A for area. If you were to imagine this happening, and like you're watching a video or whatever of this happening, is the area changing as this is going on?
Yes.
Yeah. What's the area doing? It's increasing. It's getting bigger. Okay? So here's your second question. Should I leave it as the letter A, or should I try to change A to some other variable that I might be using in the problem? I actually should leave it, and the reason why is that I'm going to leave it as an A is how else am I going to get dA dt when I go to derive in the next step? Okay, I need to leave it as an A, because when I derive the next one, I need to get that piece of dA dt. Yes?
Is there ever going to be like
There will be.
time where we have to change it?
Yes, there will be in today's examples, especially where you'll have to change it, or sometimes even just plug in a constant value right up front. Okay, so you'll see all three cases today. Okay, so the next variable is R changing throughout this problem, yes or no?
Yes.
Yes. Should I leave it as R?
Yeah.
Yes, because how else am I going to use that drdt piece that was given to me? So nothing's left over, nothing's scrapped. We use everything that they give us, and we're also going to be using those letters to find out all the unknowns. Yes?
How come you don't plug in like 4 for R right there immediately?
That's a very good question. And this is why you have to ask these questions before you derive, okay? You have to ask these questions before you derive. If you plugged in at the beginning, what is your function now? It's just a constant number. And what's the derivative of any constant? 0. All these answers would just be 0. You understand? So we have to always differentiate first, and then we plug in. Okay? But we only do that for pieces that are changing. If we have pieces that are never changing, we can plug it in right at the very beginning. Okay? Alright. That's why this changing is huge. Alright. So now we're going to derive. What's the derivative of the left side? What's the derivative of A? dA over dt. Remember, we're always in respect to time with these related rate problems. Here we go. Pi is a constant. I'm going to put it by the door. Constant multiple rule. What is the derivative of r squared implicitly in respect to time? 2r dr dt. With multiplication existing right here and here. Now let's bring the pi back in, because we're multiplying it per constant multiple rule. And guys, there is my differentiation piece. I've asked the two questions, I differentiated implicitly, and now this is my, just like on the first slide, the pieces that I'm going to substitute and solve for. Okay? I do know what r is. They gave us r. R was 4, so I can put that here. I do know what dr dt is. I can put that there. And my final answer will be dA dt is equal to 8 pi. Now let's think about this. dA dt. A is area. So what do you think my units of measure are going to be? Feet squared, because feet squared is area. But it's not just feet squared, it's feet squared per second, because it's talking about a velocity. This right here, I'm only boxing so you can see it in the video and see it from where you're at. This is my final answer, but the way I want you to be able to give me this answer are two ways. One, the way it's written right there, and then the other one in a sentence. Okay? Watch these the way I word these, and you can go back and watch the video if you need to, or write them down now. You can say A, the area is changing at a positive 8 pi feet squared per second. You with me? Or you could say the area is increasing at this positive. Okay, at this positive 8 pi feet squared per second. Are you with me? You'll see the difference with the other examples that we do here in just a bit. Any questions? And again, if you can't copy everything right now, you can go back and watch the video. I need you to engage in the other problems that we need to get exposure to. But before we go,
Why did you say it's squared again?
because area is two-dimensional. So an area is like a plane. It's not like a height of a soda can, that's just linear. But an area is like the base of that soda can. So feet squared is why it's squared. Okay. So the next one is about a level 5. And let's look why it's a level 5. It says, water runs out of a conical tank. So here's a conical tank. And the conical tank has a 5 feet radius. Okay. And the height is 10 feet. Okay, so let's look at how fast is the water level sinking when the water is 4 feet deep. So let's imagine that it's 4 about right there. And we're looking at the water here. And yes, it's leaking out. So when this height right here is 4 feet, we want to know how fast the water level is rising. Alright, so now let's go through the acronym.
Rising or sinking?
Oh, sinking, my bad. So here we go. The diagram, I think that's pretty good to go. You have enough information there right now drawn. Let's now write the rates that we are given and the rates that we're looking for. What is the first rate that we are given? 2 cubic feet per minute. What is that? D something dt.
DR.
What does this represent? 2 cubic feet per minute is d what dt? Volume. Because cubic feet is 3-dimensional. So we're going to use V for volume. The rate of change of the volume in respect to time is 2 cubic feet per minute. Should it be negative or positive? It should be negative because it is sinking. So that volume is decreasing. That's why it's going to be a negative. And you have to get all these context clues from just reading it, okay? All right. Which one is the rate that we're looking for? How fast is the water level sinking? Okay, so water level, let's say that it's height. Okay, so we're trying to find what is dH dt when what? When the water is 4 feet deep. So when the height is 4 feet deep, what's the rate of change of the height? How fast is that thing just going down? Okay? Alright, so now let's go to our equation. What equation, and you can circle it on that formula chart, do you think we're going to be using for this problem? The volume for a cone, and you're right. It's 1/3 base times height, big B. So 1/3 big B is pi r squared, and then times height. Okay? Here we go. Now the big one is asking ourselves these 2 questions. Here we go. Let's start with V. Guys, is V changing throughout this problem?
Yes.
Yeah. The volume is changing. What is it doing?
Shrinking.
It's shrinking. Okay. So should I leave it as V? Yes or no?
Yes.
Yes. Because how else are we going to get dV dt on the next step when we derive? Okay? Let's go and skip to H. Is the height of the water changing throughout this problem? Yeah. Should I leave it as H? Yes, because how else will we get this piece when we derive the next step? Now we come to R. Is the radius of this water right here, is the radius changing throughout the problem? Yes. But should we leave it as the radius? No. We should not leave it as a radius because we were not given dr dt, nor were we being asked to find dr dt. So we need to kind of translate it to a different language, and it's all about the in terms of. We need to write R to be in terms of H. I know it's been a while. But way back when you guys did similar right triangles in geometry, that's exactly what you're doing here. Okay, like triangle ABC is similar to triangle DEF. So let's get a proportion going on. R is to H from my original one as 5 is to 10. Notice that I didn't use the 4. For points, can someone tell me why I didn't use the 4? Why didn't I use the 4 here? Why did I choose to use 5 and 10? Because okay, so here we go. A lot of you did say it. This is the reason. I heard it from 3 different people. There were a consistency, like we all know similar triangles, this ratio is going to stay the same forever. We know that. But we also want to use the constant one that doesn't change. Does the tank change throughout this problem?
No.
Hopefully not. No, it's staying the same. The water changes, but the tank is constant. That's where we're going to use this constant piece here from the original shell, if you will, of the tank. Okay? Here we go. Guys, if our goal is to find R in terms of H, which one do I try to get by itself? R or H? R. Okay? So we're going to solve for R, and we're going to say R is equal to H over 2. 5/10 reduced to 1/2. Multiply both sides by H, we get H over 2. And now what we're going to do with this is everywhere where we saw an R, we're actually going to plug in what it equals in terms of H. So we have let's say pi over 3, we have H over 2 squared, and then times H. Again, where there used to be an R, I'm now writing it in terms of H. Yes?
So when you were solving for R, can you still not plug 4 in because you're trying to find
Correct.
dh over dt?
Okay.
Does it not matter that you already have an H side to multiply?
Okay, so, yes. So substitute and solve. Here is where you want to plug stuff in, okay? But I also remember telling you, you have to ask your questions there for before deriving. We haven't got there yet, okay? We're still on the equation. Okay, so don't plug anything in just yet, okay? And in terms of this, H is equal to 4. Okay. Now, what do you think I should always do before derive? Simplify everything, okay? Try to simplify everything before you derive. Hopefully you remember from Algebra 2 that this 2 is going to distribute to both the top and the bottom. So you have H squared over 4. And if I simplify this out, I'll get pi over 12, because that 4 and that 3 multiply together. Make it a little bit more legible. Pi over 12, and then I'm going to have H cubed. Okay? So just like Tyler was asking, this is my equation right now that I can say, all right, it's simplified, it's written in terms of H, no R, so now my asking questions are complete as well. Okay? Now, let's go ahead and derive. What is the derivative of the left side? dv over dt. Now remember, you're always taking it in respect to time in this unit. What am I going to put over here near the door for constant multiple rule? Pi over 12. So all I need to do is derive H cubed. What's H cubed derived? 3H squared times dH dt. Multiply the pi over 12 back in, and there is your running answer so far. Okay, and then the last part is just substitute what we know and solve for what we don't know. I'm going to plug in for H, I'm going to plug in 4. So let me highlight that. Right here, this 4 is going to plug in for H. What else can I plug in? Negative 2. So this negative 2 for the dv dt is going to go right here. So we have negative 2 is equal to, I'm going to reduce this, guys, to pi over 4. And when I plug in this 4 for H, I get 16 because it's H squared. And then the only thing I'm looking for, it's just basic algebra 1 from here, is dH dt. 16 times pi over 4 reduces to what? 4 pi. So let me come over here with the work. And I get negative 2 is equal to 4 pi dH dt. What am I going to do at the very end? Divide by 4 pi, so that I get negative 2 over 4 pi. Or you can reduce it further to say dH dt is equal to negative 1 over 2 pi. Now we just got to do units of measure. Height, is that 1 2, or 3-dimensional? That's 1. What's my unit of measure here? Feet. So it's not going to be feet squared. That's 2-dimensional, like area, the other problem that we did. It's not going to be feet cubed, that's volume. This is going to strictly be feet for what? Per second. And you're going to be done. Questions? Oh, is it per minute? My bad. Thank you for that. Alright? Alright. Any questions before I move on? Okay. So the next one is looking at, depending on the way you see the problem, I think this is like a 6 to a 7 as far as level of difficulty, just because of what you're trying to see as far as pieces to set up the equations and whatnot. Here we go. So, a fish is being reeled in at a rate of 2 feet per second. Let's write an equation right now from what we've just read. Chances are we can't because we don't know what the picture looks like. This is why I keep stressing the diagram drawn first would be better. So let's read more so we can figure out what the diagram looks like. From a bridge 16 feet above the water, at what rate is the angle between the line and the water changing when there are 20 feet of line out? So if you've been fishing, you probably can imagine what this looks like, the diagram immediately. If you haven't, you might have to read this a couple times, pretend that you went fishing, and then you can draw the diagram, and the diagram will look something that looks like this. So we're going to say that you are fishing on this bridge, okay, and here's you, and I know some of you are going to be like, well, it's at 16 feet above the water. Shouldn't the bridge be 16 feet above the water? The context of this 16 feet above the water is just where the actual fishing pole is going to have the line coming out. Okay? So all that I highlighted in green is 16 feet above the water. Alright, so let's say that here's the fish, here's the line, and all of this is the water. So let's say about here. I'm no artist, but it's close enough. Alright, so here's like where the fish is at. Alright, so the diagram's pretty good. What else could I add to the diagram based off of what we read? Go ahead. Perfect. Hypotenuse is going to be 20 feet of line out. And again, guys, this is the hypotenuse. The hypotenuse is this piece right here. That's the line. What else have I not labeled that I could label? Theta, the angle. So theta, this angle, is between the line and the water. Okay? And then, last but not least, I'm going to label Z, Y, and X. Triangles especially, guys. Any horizontal length from now to the end of the year, whatever, label it as X, please. Almost like the X-axis. Any vertical length, label it as Y, like the Y-axis. And any diagonal, label it as Z. Don't use A, B, and C. Because A through E, I've taught you to interpret those as constants. I want you to use X, Y, and Z. Okay? Alright. Here we go. So, the diagram is pretty much good to go. Let's look at the rates that are given and the rates that are unknown. What could we write for the rates that are given? 2 feet per second. So, d what dt is 2 feet per second. D what? Not dr. Based off of the problem, a fish is, okay, I see why you're using r because of the reeled in. But because of the reeled in, this line is represented by z. So we're actually going to use dz dt. Okay? So dz dt is the line being reeled in, and we're going to put it as 2 feet per second. But there's something still wrong with that. It needs to be what? It needs to be a negative. Okay? Now watch. The reason why this is negative, it's not because it's moving to the left. It's not because something is falling down. It's not because something is going backwards. The reason why it's negative is because z is doing what? It's decreasing. If f prime of x is positive, we know f of x is increasing. If f prime of x is negative, we know f of x is decreasing. Huge. Okay, otherwise there's a bunch of negative mistakes just with that. Okay? Alright. What is the one that we don't know that we're looking for? D what dt? D theta dt. So d theta dt is equal to what? When z is 20 feet. Step 2, done. Now the next one is, what is the equation that's related to all this mess? What equation are we going to do to tie in all this stuff?
For x, can you put 12 because you know it's the 3-4-5 rule?
You can put 12, but we don't need it just yet. You might be jumping a little bit too ahead. It's all good, but yes, it is 12. Okay? What's the equation that we're going to use from the pieces that you see that were given to you? What would you say? Sine. Okay, we're going to use sine because we have theta, then we have its opposite of 16, and we have its hypotenuse of 20. Okay? So I'm going to use sine of theta is equal to, this is the question that Tyler kept asking from before, is equal to y over z for right now. Okay? Equation is done. Now let's look at A for the asking of the two questions. Guys, is theta changing throughout this problem? Try again. Theta is changing. Because when you reel this in, theta is increasing until you just pull the fish straight up. And if you haven't been fishing, get out more, please. Is y changing throughout this problem?
Yes.
Y is not changing. Y is going to always be 16 feet above the water. No, let's pretend he's not doing that. So he's just doing this. Alright? So 16 forever. That means right now, before we derive, we're going to plug in 16. The reason why I plugged it in now is because it will always be 16. Constant multiple rule. Is z changing throughout the problem? Yeah, it is changing. That line is decreasing. Okay? So we're going to, should we leave it as z? Yeah, because how else are we going to use this piece? Are we good? So now we're ready to differentiate implicitly with respect to time. Anyone, what's the derivative of the left side? Cosine of theta times what? Times d theta dt. Now look, 16 over z, I know 16 is a constant. You can pull it out, and you're left with that 1 over z, to where if you wanted to rewrite this 1 over z as z to the negative 1, the way I've been suggesting to you, if the top term is one monomial and it's just a constant, I would bring that bottom term up with a negative. Because now the derivative of this is negative z to the negative 2, which is negative 1 over z squared. Multiply that 16 back in, we get negative 16 over z squared. But what is it that I still need to multiply by that I haven't yet on the right side? dz over dt. Okay, so dz over dt is that implicit chain rule last piece, because we are always in respect to time. Okay. Now it's just substitute and solve. Z was given to us as 20. dz dt was given to us as a, well, we figured it out, it was a -2. We're looking for d theta dt, but we also have theta. So cosine of theta. Right here, it looks like it's unknown right now. But we actually do know cosine of theta. Or we could find cosine of theta from all the pieces that were given to us. My hope is that you don't try to do, I know that the sine of theta is equal to 16/20. My hope is that you don't do this. If I take the arc sine of both sides, then I'll have theta alone. Then whatever that is, I'm going to then take the cosine. It's too much work. If you use a reference triangle, just like Cooper was way ahead of the game in showing us that this is a 3, 4, 5 right triangle, this would be 12. So if I just do the cosine from here, it's just the adjacent over the hypotenuse, which is 12/20. So 12/20 times all of this other stuff that we have. Let's put the other stuff. The next problem that we're going to do, you're going to do in groups 4 bonus points. So we have -6/16/20 squared times -2. And you can use a calculator if you want, or you could do this by hand. Tell me real quick, what do you get for d theta dt? If you can see the algebra, you're going to multiply the right side by 20/12. Okay? That would cancel this out. And now all of this is my answer, whatever it equals. We see one of these 20s cancel with that 20. You can see this 2 reduces this 12 to 6. So you have a -1 up top, you have a 6 on the bottom. And then you can just simplify from there. So right now I have a -16/20 times 6. Again, if you can correct that, I'll give you participation points. But this looks to be our...
Wouldn't it be a positive 16 because that's a -1 when you multiply it by?
Yes. So -1 times this negative would give me a positive. So it's a positive 16/20 times 6. So 16/20 times 6. What would that be reduced? Well, you could have reduced it over here. This could go to 3. That could go to 8. 8/60, right? Which would be 4/30. And that doesn't reduce anymore. 2/15? Okay. So, yes, it is. My bad. So 2/15 is my final answer. And what are my units for my final answer? If it's d theta dt. Not degrees, radians. So right now, all year, we're just in radian mode in Calc. We're not in degrees ever. Don't ever have a calculator. When you do menu, home to menu, C, okay, it defaults to radian. Okay? So make sure you know that because someone missed a 5 a couple years back because they were in the wrong mode. Okay? So it is in radian mode, so you'll put radians per what? Second. And that is your final answer.